we'll have an interesting presentation. We'll cover the market. So I start briefly with introducing the solution, but then we'll take a few steps backward to talk about the market. In the previous session, people mentioned what is the market and where are we playing. So just the trends, not all the trends where play the dominant role in defining our solution. So first, a little bit about the big picture. Big picture is data keeps growing, and the more data that you have, you need a scale of 10x, about 10x. There is no right figure to put in here, but the scale is much larger to be able to compute the amount of data and to make it more usable. Otherwise, it's just spending money on storing the data. And this brings a lot of challenges to the customers. You see that they have compute, networking, storage, energy, space, software. It brings all the challenges when you're trying to scale that fast and utilize the data and not spend money on storage without really utilizing it. And we kind of estimate, and we see the discussions that the hyperscalers are spending about $1 billion plus every year on growing and scaling their data analytics solution. So what we see here, if we take the TPCH query per price, the performance per price, and we see that, yeah, you can improve the performance, but it costs you more and more in order to be able to really scale. So we observed such a trend, and what we are trying to come with a solution that will unlock our customers and that they will be able to scale and not blow up their expenses completely out of the roof. So we came up with an accelerator that basically we call it an SPU. Very common XPU name for aligning with the market trend of naming, at least. It is a design that is purposely built for data analytics. So we are not leveraging any hardware or compute chip that was built for a different task and trying to see how we can use it with software-only solution and try to squeeze as much as possible. It was designed from scratch for data analytics and the challenges that customers have. So it is designed for modern. So in the previous slide, in the previous presentation, there was a question: who are your customers? Our customers are in the cloud or hybrid cloud or cloud native architecture. So they can be on-prem, but it will be a cloud native because it is a higher scale. And the goal was to build something that they can easily integrate in their software ecosystem. So aligning with starting the integration with some of the most common larger scale or growing scale workloads, Spark, Presto, Lakehouse, and we have some customers that take our API and connect it directly to their data analytic tools. This is also possible with the API that we are delivering, and you will hear more about it in our product presentation. And of course, it comes in as a PCIe card that you are able to integrate it and connect it in your server as is without changing or doing any crazy modification in your hardware. So now I'll take a little bit a step backward into the market trends. I hope that I'm not discovering any new market trends for you. I don't think so. But those are the market trends that helped us really define what we need to how to define our solution and how to build our solution. So, this is so basic. I was considering if I want to include it or not. Data is growing. Everybody knows that. But I wanted to include that because we see that organizations are collecting more data and they are finding new business opportunities, either finding more customers, more opportunities, improving their service, or even improving their operation or cost. So data is being utilized in many ways and can be structured and unstructured data, but we see massive amount of data that requires even larger amount of compute into your ecosystem. You disagree?
No. Yes, no. So apologies if this isn't your target audience, but just out of curiosity, moving away from the buzzy side of AI and ML, let's say you're an organization that you either want to go the LLM route or you want to go the AI route and train it with ML workloads and engines and stuff like that. And let's say you're that company, would you want to use NeuroBlade's SPU to lower costs from that perspective, or is that not really your target audience?
It's not the target audience. It can be as
Yeah.
part of the ETL process, for example,
Got it.
when you want to arrange your data to be able to be processed. So the ETL process will be much faster.
Right.
We've seen it tens of times faster, which helps you utilize your infrastructure, because the GPUs are not waiting there just for the data to be ready. It's done fast.
Even the models to be trained would be much faster as a whole.
Yeah, so you will be able to filter your data much better and much faster.
Got it. Cool. Thank you.
Okay. So the next data trend, again, it's a trend that is happening for years. I'm not discovering anything, but we have to take it into the consideration when we define our solution and when we define the customer target. So we see customers are moving for more of a vertical warehouse solutions. Vertical meaning it's on-prem. You know what hardware, what piece of hardware you're running, and it's more I would call it in control environment, versus a solution that we see customers adopting for years and keep moving into a kind of a data lake or data lakehouse. Data lake helps you really utilize lower cost object storage and share your data between your different data analytics workload. So everyone is sharing the data. Problem with data lake was kind of the performance. It can scale efficiently, but performance was not that great. So they came up with a hybrid solution, which is a data lakehouse, that you have a metadata layer between your workloads and your object storage that holds the metadata, caching, or whatever helps the application find the data faster and utilize it. So you get the best of both worlds. Again, scale at a reduced TCO.
So a question for you there. Obviously, the two market leaders are Databricks and Snowflake for the far right, both public cloud solutions.
Correct. Yes.
Where do you guys fit in?
We'll talk about it, but definitely this is a place that we have to meet our customers. So one of our customers will be one section of our customers, and a critical one is the public cloud vendors, to see how we can offer an acceleration on their infrastructure. This is definitely a...
So my point is more, isn't your customer Databricks?
Also can be. It can be. I'll talk about
Snowflake, or am I missing something?
It can be. I'll talk about it in the next, I think in 2 slides, I'll talk about it, but definitely there are a potential. I don't want to mention any names here, but meeting our customers in public cloud, where it is growing, definitely we are looking at that, and this is the way we built our solution.
Are there certain regulated industries you're targeting as well?
Yes.
Any specific ones you would like to share?
Yes, I don't think that they will be happy for that.
Understood.
I think one of the easiest one is the one that Elad shared, that healthcare providers can use our solution on their on-prem, so they acquire it from a partner, a solution from the partner, data analytics partner. So this is one regulated, but we have much more regulated customers, yeah.
So I'm assuming with the design of this is pretty much more data warehouse than it is a data lakehouse. I mean, I understand the data lakehouse because you're ingesting both unstructured and structured data in there. You're exiting that data lakehouse with it structured, so you can query against it. So yes, that would be a Databricks and a Snowflake environment that you'd be operating in, but it sounds like you're really targeting those guys that have got very large structured databases with the SQL queries.
Yeah, this is a great comment, a great question. And the way I think is the best to answer it, think about it like we are a CPU that can do data analytic work or SQL or query work much faster. So it's like the CPU will have an instruction set that runs faster the SQL operation. That's the best. So whatever this ecosystem work in the data, wherever it is in each format, this is what we can do. Yes, we can speed up today's structured data, but it's not a strong limitation. Just a focus of the product. Small company need to focus. We have big enough market, big enough problem to solve, and this is where we are focusing on.
And I'm assuming that what you're doing here is with the SPU, I want to say DPU, but the SPU, you're overcoming the problem of memory, server memory, that you need a very large memory in order to do your queries, and because you're not, because
all of that, we take the data directly from in the format that it is, from the storage. Storage can be wherever it is, and we push it back,
and then
push
you
it
take
into the accelerator.
So you're getting it close to memory speed in terms of doing your queries and then putting that out. Okay, thanks.
I actually have a follow-on to Ned's question, backtracking a bit. Without naming specific customer verticals, is it just fair to say that large enterprise customers with a lot of data that they're not moving out of their data centers due to data gravity or regulatory reasons or whatever are a primary target for your go-to-market then?
It's not the primary. They are the first one to be able to adopt it because they have full control. They are very vertical. They know exactly what they need.
Okay.
They have lots of data and they need fast results. And they have lots of money to invest into do the deployment themselves. So they take our API and they go crazy on top of that with minimal help from our side. We don't even know what they are doing except using our API and come back with bug fix request.
Do you have a target size customer you're going after in terms of the size of their data warehouse or the data lake that they're wanting to say to justify what you're offering?
Yes, of course. But we'll talk about it.
Okay.
But all the public cloud vendors and private cloud vendors, hyperscalers are part of the customers, and we are talking with many of these, more than 50%. Okay. So another trend. This is kind of something that helps us put more work on us. Is the open standard of data analytics and formats that we see. It's basically a disaggregation of the software in the software infrastructure layer. So we see that different query engines can support different table or table format, file format, and they want to run on a different storage solutions. This gives our customers the flexibility to use the best of each world and utilize the best query engine in the table format that best fit for them in the storage that is more efficient for them. No vendor lock. This is perfect for our customers. For everyone that delivers a solution, doesn't matter if it's a software solution or hardware solution or a combination of the two, it's more work. We need to be able to support all these formats, and this is where we talk about the focus, which customers we go first and then which customers we follow on later on. Usually it's the first adopters, customers that really can take something new and develop on top of that, test it, and help us make sure that our product is the best fit for them. So this is the third trend, and this is the one that we talked about. Data analytics is growing in the cloud. We see a big growth of data analytics in the cloud. So this is where we need to meet our customers. It can be in the public cloud as part of their data analytics as a service. So we need to work with their data analytics as a service team. Of course, they have their own internal data analytics that they are running. So we need to work with this team as well. And they have service provider, many names mentioned, that are doing data analytics solutions. And we need to meet these customers as well. So there is kind of a 3-point discussion. And actually, it's more than 3 points because we need to talk with the infrastructure team because we need to make sure that our cards can be plugged into the infrastructure. And we need to make sure that the user, the end user, the data analytic user, either if it's a data analytics as a service or internal data analytics, can utilize this card with our software stack. I don't want to go into this, but you see where we can meet our customers. It's not that we are addressing all the V's, all the green V's here at once. It's one by one. We are a small company, focus on the first adopters and big enough customers to justify the investment. So we define an accelerator, and we thought maybe it's not a good idea because most of data analytics solutions are software solutions, but we see that more and more accelerators are used in the cloud, in the data center. We see the CPUs are used and they are growing. We see the GPUs, of course, they are growing. And suddenly we realize that the custom workloads acceleration is also growing. And it can be, the network like DPUs, analytic like our SPU, security offload, and storage offload. So we see a trend that all our customers want to scale their infrastructure. They need to invent or utilize a different way to compute. Okay? And meet the energy and power constraint. So let's talk about it. Okay, CPU. It's the easiest. It's a software solution. Everybody started to develop that. Everything is working on the CPU. Cost is okay. Availability is great. It is deployed. It is proven. It's a safe bet. What's the problem? You cannot scale. It cannot scale efficiently. Your performance is okay. It works, but it's okay. So you just need more servers, beefier servers, and you get the work done. Not the fastest that you want, but fast enough for customers to use it today, but not fast enough to scale. So let's talk about the GPU, which is today it's the ultimate accelerator. When as Elad mentioned in his presentation, this is the first thing that we went. You have compute power that is different than the CPU. Let's see if it can do that. Problem with GPUs, they are very expensive. They are not very much available. It's very hard to get them. It's very and they are not deployed. Actually, there is no proven, at least to our knowledge, a proven data analytics deployment of GPUs that we know about. At least not at a scale that makes sense. And then, yes, GPU can scale. Performance is nice. You get a 5x. You pay a lot. You pay much more. But if your main concern is performance and you don't care about cost, go for it. Some of the agencies can do that, not the cloud scale that have millions of instances running data analytic workload can do that. So not really a solution.
So
Yeah.
quick question, based on that, where would you look at AWS's services like Inferential Trainium, where they put custom silicon at scale globally for exactly the types of workloads that you mentioned?
So yeah, so AWS is very easy. They have the Nitro for DPU. They have the Nitro for storage. Actually, they are doing their own drives, which is also an acceleration. And they are running lots of storage services on their DPUs, with the latest acquisition of storage, E8, for example, to get a much faster EBS platform. So they are the first one that invented to say, okay, we need to get out of the traditional hardware server architecture and build something that is much more efficient. So they are the leader in this. Everyone else is following them. Different, their own ASIC, FPGAs, by company, different models, but you see the adoption is there for acceleration.
So do you see Inferential and Trainium from AWS, Google with TPU, Microsoft with what they've just announced, is it Maya for their custom silicon? Do you see that as competition for where you're?
Well, I don't think it is competition. One, it's not efficient. It was designed for a completely different workload. When you're designing something for a specific workload, you don't think about the consideration. So how can a TPU or a GPU can read data directly in the format that it is in the storage, Parquet format, and how can it do that? It can decode, decompress, all of that. It is not built for that. So it can do some parallel compute in some of the parts of the data flow, but it cannot do all of that. So you are speeding only portion of your data flow, because that's why you are using a very specific application-specific acceleration.
You think you can rip your manufacturing and distribution higher than NVIDIA because you're giving them a yellow and a red, and you're
it is the availability. It is availability for data analytics. If someone is buying GPU, where do you think it will be deployed? You get a better performance or value per dollar if it deploys it for AI machine learning and not for a data analytic workload. So this is what I mean for availability. Availability for data analytics workload.
Okay.
Yeah.
Okay.
When you say data analytics workloads, it's a very vague statement.
Mm-hmm.
That can mean
Yeah, I know, it's a very broad. It's a very broad, yeah.
But you're getting into specifics by putting red, green, yellow in front of us, tied to a thing called data analytics workloads. Set that aside for now. Everything that I've seen from your website basically says between the data of the customer and your SPU, there needs to be an analytical layer. Spark, Presto, something. So if a company doesn't have that, they're not going to get any value from SPU. So that's one thing. But some of those systems scale horizontally, hundreds of nodes, in order to get performance.
Yes.
Are you going to recommend hundreds of SPUs?
Yeah, and we'll tell you that you will save the amount of servers that you will need to use. Your cluster will be much lower, and we have customers, and Elad gave an example. These guys saved about 70% of their cost by using our solution.
Got it.
It's not only translated to performance. Sometimes you don't need the whole boost in the performance. You say, okay, I need a smaller cluster.
Yeah.
It's hardware to avoid having to throw hardware at the problem.
Mm-hmm.
Until you have to throw hardware at the problem again.
Yes, integration problem. And
we're avoiding throwing servers at the problem by beefing up the servers we have, I guess, right? I'm playing vendor's advocate here.
Yeah.
Okay.
Yeah. So Krishna with the product overview will address this integration question, and you will see that we are trying to meet our customers where they are, not pushing them to use or do something that is much more sophisticated than what they are doing today. There is a cost of integration. It's not zero because you are integrating a new hardware, so the infrastructure team need to be involved and the data analytics needs to be involved. How much they need to invest in it? Not that much. If they are using standard solution, like I mentioned in the previous, if it's not standard, then the problem is a bit more complicated. And if it's big enough problem for them, we will work with them and we'll do that. We're a small company, we can allow that.
A question. So I think I mentioned this in the beginning of the session around like, if you use something like this, you can have either weaker servers, they don't need to be as beefy, or maybe not even as many, right? And correct me if I'm wrong, because I'm not 100% in the data analytics space. Even with something like this, like you don't have to have as powerful of a GPU. So like GPUs are like ridiculously expensive right now, obviously, and will continue to be. But let's say you use something like an SPU, it's like, all right, we don't need to spend $2,000 per GPU. Would that be?
I think it's probably secondary or maybe a third level of benefit that you'll get. It's very hard to calculate.
Sure.
I don't think that this is the way that we can help our customers understand the value.
Makes sense.
For specific workload, it's very straightforward. We have the benchmark, and we'll show a demo on some of the benchmark to show the revenue standard benchmark. So, and then you can see the benefit. We'll dive into how the benchmark and what we are speeding exactly in these specific queries, and you'll be able to understand more about that. So basically, this is just a summary slide. We built our solution based on the trends, not the trend that we discovered something new in the trend that we discussed, but these are the trends that shaped our solution to be scalable and flexible. It needs to be cloud friendly with hardware and software integration. Yes, for containers. Yes, for virtualization. Right now, multi-tenant virtualization depends on the public cloud provider if they want to do it or not. But this is beyond our ability to forecast what they need, so it's not something that is working. And fast and efficient query processing.
Can I have a question? When you're buying this SPU card, or in OM version or standalone, let's say, do you need to buy as well some license for that, some subscription to run it, or just the hardware?
You mentioned vendor lock-in a while ago, which is a fraught term. But I'm curious, you also mentioned open source. I'm assuming your hardware is not open source, but is the software, SDK, and API, are those available as open source?
Well, some of the integration are like what we did with Meta, Velox team. So we are the first one to work with them on opening hardware acceleration support for Velox. So every time there is an opportunity to do that, yes, we'll do that. We are not concerned about sharing our API that much. Just people will not be able to do anything with it. So it's not always an open source, but we will have versions of open source if it makes sense. That's all.
The parallel nature of it, is that something that your middleware takes care of to distribute the load across multiple cards if they have more than one accelerator card?
Right now, it's optimized for one card per server.
Okay.
To fully align with the drivers. Or, we can do it one card for a VM if you are in the cloud. So per instance that a VM virtual machine that is running on this cloud, it can use one accelerator.
Okay, so from a structural perspective, if I have a massive query that I want to run, it doesn't distribute that to a bunch of different cards.
You don't need, because we actually exhaust the IOs that you have on your disk or on your network anyway, so with one card. So it doesn't make sense. You can put more compute, but at some point you need to pull the data from somewhere, and we exhaust the IOs. When the IOs will be faster, we should be able to do that. It's not that there is a limitation in the just lack of need and focus right now.
Okay.
So a follow-up question, is this then to try and look at something like a MongoDB? They've kind of fixed that problem by sharding across multiple servers. Are you saying you don't need to go beyond the confines of one server because you can do all that performance?
We don't do the sharding. The sharding happens above our head. However, the data analytic tool or the Presto decide to do to lay out those configurations and the data. This is how we work. It's not something that we make a decision. We just get an SQL command queries and we execute according to what we can do.